Welcome to today's lesson. We will continue with our computer systems unit and look further into our computer architecture topic. Today we will be looking at the processor or CPU. Here are our learning intentions for today. At the end of the lesson we'll be able to describe what a process is, explain what the CPU is and name its different parts, explain what each part of the CPU does. We'll also describe how clock speed impacts on CPU performance, describe what a microprocessor is, and explain the process of the fetch execute cycle. Here is our success criteria. We should use this to measure the success of our learning throughout the lesson. Again, this should be referred to periodically throughout our lesson. Let's start the lesson by looking at a process. Get an understanding of what a process is so that we can describe it later on. Basically, a process is an operation that is carried out on any input to a computer system which will give an output. In the example that we have here, we have a maths problem where we have two inputs, two numbers, and we have an output, another number. In this case, we have 2 and 2 being inputs and 4 being our output. Our process is the operation of addition. So we add both inputs, 2 plus 2, the process of the operation being the addition part that is carried out to those inputs, giving us a resultant output of 4. So therefore our process would be addition in this case, or subtraction, multiplication, division for any other mathematical problem. This is just one example of a process. The processor, or the central processing unit, CPU, conducts all the processes or tasks that are required by the user or the computer system itself. It is a very important component within the computer system. It is sometimes referred to as the computer's brain. The processor, or CPU, is made up of 3 main parts: the ALU, the CU, and the registers. In the following slides, we will look at each of these parts and what they actually do. The first part of the processor we will look at is the ALU, the arithmetic and logic unit. This part of the processor has the function of carrying out any arithmetic calculations or logical comparisons that are required within the execution of a process. The example of the process we gave earlier with the addition sum would be carried out by the ALU. The next part of the processor to discuss is the CU, or the control unit. This part of the processor does all the fetching and executing of instructions. It also decodes those instructions to understand what is required within the instruction. Is there a calculation or a logical comparison required? If that is the case, then this part will be sent to the ALU to be carried out. The control unit also has the function of ensuring that all the processes are executed in the correct order and at the correct time. It uses something called a clock pulse to do this. We will look at the clock pulse and clock speed later on in this lesson. Finally, for the last part, are the registers. The registers are lots and lots and lots of very small but very fast pieces of memory that are located on the processor chip themselves. They are used to temporarily hold data or instructions that are being carried out within a process. They are stored in the registers because they can be accessed very, very quickly. They're the fastest type of memory that we have in our computer system. Earlier, when talking about the control unit, we mentioned a clock and clock speed. The processor has a clock that controls a regular stream of electronic pulses, and that manages the timings of all the tasks. Clock speed is a measurement of processor performance. It's not a very accurate measurement of processor performance. There are other more accurate measurements of processor performance, but the general rule is the faster the clock, the faster the processor. Clock speed is generally measured in megahertz or gigahertz. What does this mean? Well, an 800 megahertz clock has 800 million cycles or ticks per second. That was the speed of the processor in the iPhone 4. That device has evolved many generations from then. Its processor is far more powerful, and its clock speed is far greater than it was back then. The term microprocessor is commonly used within the world of computing science. A microprocessor is basically the silicon chip which contains all of the components of the processor, where everything is brought together and collated into one single unit, as shown in the image below. In this case, this is an Intel Core i7 processor. It is quite a modern processor and quite a powerful processor. Silicon is the material used to produce these chips. To finish off this lesson, we will look at the fetch execute cycle. The fetch execute cycle is an instruction cycle, and it's the basic operation process of your computer system. The system receives instructions and determines what is required and then executes the instruction. This is a continuous cycle. The diagram in this slide shows the cycle. Instructions are fetched, decoded, and executed. This is a continuous cycle. Instructions are normally fetched from the relevant memory address and placed in the register. They are then decoded by the CU to understand what is required with this instruction. The instruction is then executed. This process will involve the CU passing signals to relevant parts of the processor. For example, perhaps sending data to the LU for a calculation or logical comparison. The results would then be written back to memory. Again, the fetch execute cycle fetches instructions, decodes to understand what is required by the instruction, and then executes the instruction. This is a continual cycle.